Welcome to The Edge, the podcast that looks at what's happening next in Canadian innovation. I'm your host, Kate Kenyon. Here at Mitacs, we're at the crossroads of innovation in Canada. Every year, hundreds of companies and thousands of researchers come to us looking to combine their ideas to make innovation happen. This gives us quite a view. We get to see what the brightest minds are coming up with all over the country. We've got stories to tell, and we want you to hear them. Robotics, artificial intelligence, fashion, athletics, conservationism, whatever it is that makes you geek out, Mitacs is on the cutting edge. This is a podcast about what's next, about what emerging Canadian innovators are doing to improve our world. This is The Edge. Episode 3, Halting Hypoglycemia. Dana Greenberg hasn't slept through the night in 15 years.
It's all consuming 24 hours a day when you're awake, when you're sleeping, and someone says, well, how do you think about it while you're sleeping? Well, that's another big challenge. I don't sleep so well.
Dana and her daughter Marley have type 1 diabetes. Marley was diagnosed 15 years ago. Through the night in their Toronto home, Dana keeps an eye on her and Marley's blood sugar.
And if I see her blood sugars are going low, I just go and I wake her up, give her some juice, give her some food, as long as she doesn't fight me. And I have to really say, no, your blood sugars are low. You need to eat. But if you don't wake up and don't consume the food, you will not survive till the morning. It doesn't take that long to pass away from it. That's a real risk.
Diabetes affects 1 in 10 Canadians. It's a disease whose name we all know, and a lot of us are familiar with a few of the basic facts too. There's a type 1 and a type 2. It's something to do with blood sugar, and diabetics use insulin. But it might come as a surprise that for diabetics like Dana, sleep can be a source of great fear and even a matter of life and death. But why is this, and who are the scientists in Dana's very own city who are working on a solution to let her and all those living with diabetes finally sleep easy? I spoke to Dr. Michael Riddell, senior scientist and diabetes expert, to start at the beginning.
In the simplest way to explain it, diabetes is a disease of poor blood sugar management.
Michael works for Zukara Therapeutics, a Toronto biotech company focused on diabetes research, but his connection to the disease is also personal.
I have type 1 diabetes. I've been living with this disease since childhood, but diabetes means either high or, with treatment, low blood sugar levels. So in a nutshell, it's just sugar mismanagement.
Like 300,000 Canadians, both Dana and Michael have type 1 diabetes. This is an autoimmune disease that appears during childhood and adolescence. Its cause isn't really known, and there is currently no cure. It's a disease characterized by high blood sugar. This is because type 1 diabetics cannot produce insulin, the hormone that stops blood glucose from rising too high. Humans need glucose. Our brains cannot function without it. But type 1 diabetics cannot regulate the glucose they eat. Their blood sugar skyrockets without the insulin needed to bring it back down to safe levels. So, for people living with type 1 diabetes, taking insulin from an external source is essential. It keeps them alive.
In the healthy non-diabetes person, insulin is a hormone secreted from the pancreas that goes up and down throughout the day. Its job is to control your blood sugar. So when you eat a meal, insulin would go up naturally to help keep the blood sugar in a normal range. Now, in diabetes, that's dysregulated. And so insulin becomes a hormone that people have to take by injection or by an insulin pump.
But while taking insulin solves one problem, it creates another.
Insulin's really tricky to take. You have to take it by needle or by infusion in a pump. And you can just, on occasion, take a hair too much, just a hair, a whiff, and blood sugar gets too low. And that's called hypoglycemia. It is immediately dangerous because people can lose their thought process, their coordination. They can not only lose their energy levels, but they can become confused. They can pass out and they can even die.
This is what's keeping Dana up at night. Hypoglycemia, or low blood sugar is an ever-present threat that she must guard against, both for herself and for her daughter.
We have a risk of going low through the night and we won't feel it because we'll be sleeping. Listen, I've lived with it all my life. It is that much harder, a million times harder as a parent. I think other parents can recognize the worry that we have for our own children are that much greater than what we fear for ourselves. I think for most people, you have high cholesterol, you take a pill. You have irregular heartbeat, they put in a pacemaker. And people think, oh, you have insulin. You're managed, you're healthy, you're well, it's a cure, and that's it. It's like a pacemaker. You put it in, you're done, you don't have to think about it. No, insulin, although it keeps us alive, and even though insulin has improved over the last 100 years since it was first discovered, it's still not perfect, and it still causes the hypoglycemia.
Hypoglycemia is known within the diabetic community as going low. By using their insulin to stop their blood sugar going too high, Type 1 diabetics run the risk of accidentally sending it too low. Dana and Michael know a thing or two about what this feels like.
When we say going low, experiencing hypoglycemia, what is that like?
You could be shaky, sweaty, weak, heart palpitations. Most of us, I would think, feel, at least for me, a lot of brain fog, a lot of brain confusion. Your brain just can't work without blood sugars.
If you were to see someone who's having an episode of low blood sugar, you might think they're drunk or intoxicated. Because if they're treated, they'll recover pretty quickly, maybe within 10 minutes, but there'll be that embarrassment because it occurred at work or it occurred in the school ground, in the most inconvenient place throughout the day. So it's frustrating, it's embarrassing, and the symptoms are actually pretty scary if they're more severe.
During the day, people typically feel hypoglycemia symptoms coming on, and they can do something about it by eating something. But at night, you might not feel anything at all, and this can be potentially life-threatening.
Low blood sugar can occur at any time of the day. It can occur during exercise, it could occur before a meal, after a meal, but if it occurs overnight, and probably over 50% of events occur overnight, the problem is you're sleeping and you don't feel any early warning symptoms. So that means that overnight, if your blood sugar drops deeper, you can go into hypoglycemic seizure. You can have convulsions, and it can cause a phenomenon called dead in bed, where it can actually kill people. Now, it's not that common, but I have met mothers and fathers who've lost children to that episode of dead in bed. The child goes to bed completely fine. Everything is looking good in their life, and then a severe low blood sugar reaction occurs, and it's just a catastrophic event.
Dana wakes during the night to ensure a catastrophic episode of hypoglycemia never happens to her daughter. By watching Marley's blood sugar levels on a continuous glucose monitor, Dana can stop hypoglycemia in its tracks as soon as it starts by waking Marley and giving her fruit juice. This exhausting strategy is understandable. If severe hypoglycemia isn't stopped quickly, it soon becomes deadly, and the only available option is emergency rescue.
The emergency treatment is an injection of a hormone called glucagon.
Glucagon is insulin's lesser-known opposite hormone. While insulin stops blood sugar going high, glucagon stops it from going low. Non-diabetic people naturally produce these two hormones in perfect balance, but type 1 diabetics cannot. This leaves them with no choice but to inject emergency glucagon when severe hypoglycemia strikes.
The problem with that injection for the last 30 years is that the injection has to be formulated either by the parent or healthcare provider, and that formulation takes time. And the person is under a situation of anxiety because they have to inject their loved one with a needle.
Emergency glucagon must be administered as rapidly as possible. It's a frightening, high-pressure situation where every minute counts. And it's not something Dana ever wants to have to do.
I've heard many horror stories about parents panicking. Like, what are you doing? How do you do it? I mean, you think about it, EpiPens are sort of automatic. You inject them and they go in. Emergency glucagon, you have to take the powder and the saline solution, mix them together, draw them out, then give the injection. I remember recently reading a story about how the needle broke. I think they sprayed out the saline solution instead of putting it into the bottle. And that's why they were very grateful that they had more than one glucagon kit in the house.
And then there are the side effects.
If we take glucagon as a rescue therapy, we actually take probably 10 times more than the body needs. So when you take a rescue therapy of glucagon, you have horrible side effects. You have nausea, vomiting, you feel absolutely terrible. This drug, again, is a rescue drug. It's saving the person's life, but they feel horrible.
I've heard it's horrible. Heard you feel awful taking emergency glucagon.
Yes, you do. Most glucagon injection, when you give it, start creating vomiting, nausea, all kinds of type of side effects. And just as a side note, if you vomit, it sends your blood sugars lower. It takes a few days just to feel yourself again. It's kind of like getting a flu. You get hit by a flu. Even a one low blood sugar, one high blood sugar makes you feel like you got hit by a flu. What they say, got hit by a truck, and you're just trying to recover.
The prospect of experiencing all this can be such a worry to people with type 1 that they'll even risk damaging their own health to avoid it.
A lot of people have such fears of going low and having hypoglycemia that they run their blood sugar so high that they're constantly in an unhealthy state. They might know that the risk of complications sooner or later are going to be that much higher, but the fear of going low is that great.
And that fear of overnight low blood sugar causes them to ride their blood sugar too high for days, weeks, months, and years, and then they can develop complications like kidney failure, blindness, nerve damage, and premature heart attacks.
I would call this the less discussed and less known aspect of diabetes. Would you agree with that?
I totally agree, Kate. I think people know quite a bit about high blood sugar and the deleterious effects of having high blood sugar. If you take insulin, you're afraid of hypoglycemia. You are afraid almost all the time. You think about it repeatedly throughout the day. If you're a parent, I have a son with type 1 diabetes. I'm afraid for him when he goes to sleep. I'm afraid for him when he goes to college, drives a car. It's something those of us who get hypoglycemia know about and fear all the time.
But Zukara Therapeutics, with help from Mitax, are fighting the fear. Alongside CEO Michael Midmer, Michael Riddell is leading a team of Zukara scientists who are working to banish the ever-present threat of hypoglycemia. Their solution? Not rescue, but prevention.
I'm Michael Midmer. I'm the CEO of Zukara Therapeutics. Zukara is a diabetes-focused company. We're developing a drug to help people that have type 1 diabetes. Our thought is to try and prevent those severe hypoglycemic events from occurring by giving a therapeutic that actually works to allow for glucagon to be released in the pancreas again.
Michael Riddell and his team of researchers set to work on one central question.
We were more interested in coming up with a therapy that could prevent the whole thing altogether. Why is it that people with diabetes can't produce their own glucagon when they have low blood sugar? We know that diabetes is a problem of insulin secretion, but they do still make glucagon. Why is it not just naturally rising during low blood sugar?
The answer is somatostatin.
The body produces this third hormone. It's already confusing enough because we've talked about two hormones, but the body actually produces the third hormone that prevents glucagon from rising during low blood sugar, and we're able to block that with this drug.
That drug is called ZT1.
We came up with a molecule that could be administered that could restore the body's ability to release glucagon during low blood sugar, and that's what ZT1 is. If we could restore normal physiology, then we wouldn't require this emergency therapy, which is, again, a matter of seconds, potentially of life and death, a matter of seconds.
Unlike the large doses of emergency glucagon administered in a crisis, Zukara's ZT1 actually targets the underlying function of the pancreas ahead of time, fixing the cause of hypoglycemia. Here's how it works. Inside the pancreas, alpha cells make glucagon and beta cells make insulin. In type 1 diabetics, somatostatin gets in the way of alpha cell function, stopping glucagon production. ZT1 stops somatostatin in its tracks, relaunching glucagon production by the alpha cells. Here's Zukara CEO Michael Midmer again to explain.
Our drug ZT1 is a way of turning that alpha cell back on, and it inhibits the action of somatostatin. So it inhibits that inhibitory hormone and allows for glucagon to be released from the alpha cell when someone's blood sugar is low, and really restore that biology to allow for glucagon to then go to the liver and release glucose. And so then we've allowed for these two hormones to work together again, insulin that they're taking for their diabetes that they need, and then ZT1 that turns that alpha cell on when blood glucose is low and really allows for glucagon to be released, for that sugar to come back up, and for that hypoglycemic event to be prevented.
How is your therapeutic, ZT1, how is that going to be administered?
We have a few ideas on how it could be administered. The simplest, what we're working with right now, is a once-a-day injection. If we're dealing with people who already take insulin by injections, it may not be such a trouble to take one more injection, maybe near bedtime, that would protect you against having nocturnal hypoglycemia for the next 12 to 24 hours. Right now, we know that we could take a small injection of this therapy, maybe into the leg or abdomen, and we've done this, and then they seem to have protection and a more robust glucagon response.
The idea is that with ZT1 to rely on, type 1 diabetics would no longer need to constantly monitor their blood sugar levels and worry about going low from taking too much insulin, especially at night.
Our drug you take every night before bed, it would prevent those lows from occurring. People would hopefully be assured they won't have a hypo event. And so potentially with our drug, if they knew they had a safety net to prevent them from going low, they might be more comfortable giving themselves insulin.
ZT1 could be injected once daily to enable type 1 diabetics to produce their own glucagon in response to the blood sugar lowering effects of insulin. The drug could be available as soon as 2028. No more worry, no more uncertainty, no more sleepless nights.
And there's really no side effects that we've seen so far. We haven't tested a lot of individuals, but we have tested quite a few, and we don't see any nausea, any vomiting, none of that when we use ZT1 as a therapy.
What makes Zukara's breakthrough in diabetes management even more remarkable is that it's part of a proud Canadian legacy.
The history of Zukara is one that dates back to the discovery of insulin, because one of our founders, Mladen Vranic, was the last postdoc in Charles Best's lab from Banting and Best.
In a crowning achievement in the history of Canadian research, insulin was successfully isolated for the first time by Frederick Banting and Charles Best at the University of Toronto in 1921, winning the Nobel Prize. And Zukara scientist Michael Riddell is something of a direct descendant of that scientific legacy.
I was a postdoctoral fellow of Dr. Vranic, who was a postdoctoral fellow of Charlie Best, who discovered insulin. And so that connection for me and others like me, because I'm not the only person with diabetes to work in his lab, feel that connection. And so that's been a lovely feeling of family for me.
CEO Michael Midmer can even see the Banting Institute from his desk.
I'm sitting right across from the Banting and Best Institute where that was discovered. It means a lot that we're the home of discovery for insulin, and that was Toronto's gift to the world. So really the discovery of insulin allowed for a lot of research understanding in the area of diabetes that has led to multiple labs and multiple new therapeutics and technologies. So I think Toronto's gift to the world was not only insulin, but also spurring a lot of the research in diabetes going forward.
Mitacs researchers are part of the Zukara team, working with Michael Riddell to push this innovation forward.
What's been your experience of having a Mitacs researcher on the team?
I've had 3, actually, but I had 2 postdoctoral fellows supported by Mitac. Without those 2 funded postdocs, we wouldn't have got the preclinical work done. We just wouldn't have got it done, I don't think. Right now, I've got a PhD student who's funded by my tax. She is a tireless worker in the lab, again, supporting Zukara, but also supporting our laboratory experiments that help to inform Zukara's drug development platform. Which drug seems to be working best? What are the side effects? What are the potentials for co-formulation with insulin? These MyTax scholars have done all that preclinical work, which is incredible. It does feel like we are all working on this together with a real passion to try to make a difference. So that's kind of fun to see these bright young minds coming and helping me as mine gets a little bit grayer and a little less bright as they carry the torch on.
It's a torch they will carry into a future in need of the light. Diabetes, both type 1 and 2, is on the rise, with the World Health Organization predicting that it will be the 7th leading cause of death globally by 2030. Type 2 diabetes is particularly prevalent, and Zukara are poised to extend their innovation to help this growing population too.
Our thinking around type 2 diabetes is that some people will eventually go on to insulin, and they'll have to take insulin multiple times per day. And they are almost like a type 1 diabetic. And they've had insulin resistance for so long that those beta cells have become destroyed. They also have issues with releasing glucagon at the right times. We've done some early preclinical research, and also we've received funding from MyTax to allow for us to develop these models in type 2 diabetes and see whether ZT1 works in a similar way. So we're starting to publish research around that. And MyTax paid for a PhD student in Dr. Michael Riddell's lab at York University to do this work. And so those grants have really allowed us to move this research forward and expand the use of ZT1. It would more than double the market opportunity if we were able to get into type 2 diabetes as well.
With the strength of Canada's track record in diabetes research, there's no telling what might be possible in years to come.
If it's emerging as possible to restore the body's ability to produce glucagon, is it feasible in the future that we might learn to restore the body's ability to produce insulin and therefore completely cure diabetes?
Well, that's another very exciting question. It's becoming clear that's a possibility. We know now that we can engineer cells that can be implanted into someone with type 1 diabetes. And these cells can secrete insulin just beautifully. You know, there's lots of great research going on. Hypoglycemia is one area, but there are people working in other areas. And that's also very exciting for me and for all of us who live with type 1, who are patients, parents, what have you.
For now, Zukara are focusing on the potential of ZT1 to change lives. And for Dana Greenberg, Zukara's innovation could mean, finally, a good night's sleep.
Well, I mean, if I didn't have to worry that Marley might go low through the night, that would be huge. My health would be improved by sleeping better. If we could avoid the risk of hypoglycemia, that is such a humongous step. Not quite a cure, definitely not a cure, but it just allows us to keep ourselves healthy, prevent complications, to feel well, do all the things that we want to do, and not worry about the hypoglycemia. And that would be amazing.
For Michael Riddell, who has dedicated his life to studying the disease he lives with, this would be a personal as well as a professional triumph.
Oh my gosh, if this drug works the way we want it to work and we think it can work, it provides a lot of freedom. So for me, I could eat much more flexibly. I could be a little bit more courageous when I take my insulin for my food. I could go for a run, a bike ride, and not worry about low blood sugar. And I would go to bed with the peace of mind that there is little to no chance that I'm going to have a convulsion and not wake up in the morning. This could be a life-changing therapy for many people who are on insulin who suffer from low blood sugar or severe hypoglycemic events.
At MyTax, we understand the challenges of experimenting with new ideas, technologies, and processes. That's why we bring together the right partners from across academia, industry, and not-for-profit organizations to achieve your R&D goals. Whether it's finding talent, funding, or networking opportunities, we support you throughout your innovation journey. Learn more at mitax.ca. You've been listening to The Edge, a podcast by Mitax, dedicated to telling the stories of Canadian innovators that are transforming the world. The Edge is produced by Catherine O'Brien and Kate Kenyon. Be sure to visit us on social media and at mitax.ca to learn more about how we can help you turn your big ideas into reality. I'm your host, Kate Kenyon. See you next time on The Edge.